How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at catalysis. Objectives. Describe how catalysts and enzymes, which are a type of catalyst, increase the reaction rate in terms of mechanism and activation energy, as well as graphically show the effect of catalysts on a potential energy diagram. So number one, how can you lower the activation energy required for a given reaction? You add a catalyst. It's like a shortcut. You know, you're like, hey, if you want to get downtown, you gotta take all these turns and go down this road, and somebody gave you really terrible directions, and then they're like, hey, wait a minute. I stopped and I asked somebody else. They added a catalyst, and now I know the most direct path. It's going to take less energy for me to get there. It's kind of like a shortcut, a chemical shortcut. And number two, the rate law for the following reaction is this: rate equals K times X squared. Which of the following will not increase the rate of reaction? Let's see, adding a catalyst for the reaction, well, that's going to increase the rate, right? Increasing the concentration of X, well, we know that the rate is proportionate to X to some power, so increasing X will increase the rate. Increasing the concentration of Y. So you would think that it would because it's reactant, but if you take a look at the rate law, Y is nowhere to be found. So no reaction, or no change in the reaction rate for C. D, increasing the temperature of the reaction will increase the reaction rate. E, none of the above. Well, choice C will not increase the rate of reaction. Number three, what is a homogeneous catalyst? Homo means the same. So if we're talking about homogeneous catalyst, it's in the same state as the reactants. That's what makes it homogeneous, right? Hey, I got all these gas reactants. I got a gas catalyst. I have all these liquid reactants. I have a liquid catalyst. I got all these solid reactants somehow. I have a solid catalyst. That's what that means. All right, for how does a catalyst increase the reaction rate? Does it change the frequency factor? No, it doesn't. Oh. It's not going to change how frequently things are colliding. Will it increase the activation energy? No, it's actually going to do the exact opposite. By providing an alternative pathway or mechanism that with a lower activation energy, yes, that is exactly how it does it, right? And by slowing down the reverse reaction, no. Or E, all of the above? Definitely not. So choice C. All right, hope found helpful. See you in class. Get back.